Assalamualaikum and good morning. I'm good to everyone. We are from Group 1 are going to present about the organometallic cluster compound which is borane. Our group member is Anis Marana, Aisyah, Nur Erina, Hamiza, Sakira myself, and Nick Nur Fatim.
Thank you to Sakira. So I would like to continue this presentation by explaining about structures and naming of boranes. So there are three important structures of boranes, which is closo, nido, and erecno, and also called as a cage structures. There exist also other structures like the hyperboranes, but they are less important. In these structures, the boron atoms are occupying the corners of polyhedron in which the boron atoms can be found together or not. These structures are often described as being polyhedral or deltahedral. A deltahedron is a polyhedron that possesses only triangular faces, for example, an octahedron. Next is, as we know, there are three important structures of boranes, which is closo, nido, and erecno. So, for example of closo, type is B6 H62 minus. As we can see here is the closo structure, which is the 6 base lies on the corner of the tetrahedron. And then when we remove one vertex, so it will become nido structure, which is there are 5b lies on the corners of a square pyramid where one corner is removed. This one corner is removed. And then when we remove another one vertex, there will be a arachno structure, which is, for example, B4H10. The 4b lies on the corners of an octahedron where two corners are removed. One and two corners are being removed. And then for the nomenclature of borane, in neutral boranes, the number of boron atom is given by a prefix such as mono, di, tetra, penta, and etc. And the number of H atom is given in the parentheses behind the name. For example, B5H11, the name is pentaborane 11, and B4H10, the name is tetraborane 10. And then for ions, we need to primarily the number of H atom first, and then followed by the number of boron atoms given and ended with the charge in the parentheses. The ate suffix is applied with only for anions complexes. For example, B6H62 minus, the name is hexahydrohexaborate 2 minus. The structural prefixes for borane multicluster are known as clado for branched clusters, conjuncto for conjoined cluster, and megalo for multiple conjoined cluster. So this is another example of structures with the naming are shown below. For example, this is closo type, which is the name is dodecahydro dodecaborate 2 minus, B12 H12 2 minus. And then this is nido type, which is the name is diborane 6, the simplest borane structure, B2H6. And lastly is arachno type, which is the name is tetraborane 10, B4H10. So that's all for the structure and the nomenclature of borane.
Now let me continue the presentation by explaining to you guys about bonding that exists in borane. So basically borane involves three center bridge bonding, which is BHB bonding. So in which one electron pair is shared between three atoms, boron, hydrogen, and boron. So a pair of electrons in the bonding combination will pull all the three atoms together. So bonding in larger borane is based on William Limcombe's methodology, where he come up with three different types of bondings in borane. two of them are 3 center 2 electrons and another one is 2 center 2 electrons. I will explain more regarding on this type of bonds in the next slide. So the electrons involved in bonding in the frameworks of boron cluster in borane is known as framework electrons. Okay, next is bonding in diborane, where it is the simplest example to explain bonds that exist in borane. So firstly, in diborane structure, diborane molecule, it consists of 4 hydrogen atoms, 2 on the left and 2 on the right side, where each side involve in formation of BH2 groups, and another 2 hydrogen atoms that known as bridging atoms involve in formation of BHB bridging bonds. So bonding in diborane may be explained on the basis idea of 3 center 2 electron BHB types of bond. So what does it mean by 3 center 2 electron is when there is a chemical bond in which 2 electrons are shared between 3 atoms. So in BHB bonding, there are 2 boron atoms. Each boron atoms contribute with 1 valence electron. So when there are 2 boron atoms, the total number of electrons contributed is 2. So therefore, it is known as 3 center 2 electron because there are 3 atoms, boron, hydrogen and boron, and also those 3 atoms share 2 electrons. So the covalent bonding that involved in this diborane is when 2 atomic orbitals of the same symmetry and similar energy will linearly combine with each other, and they will form molecular orbital. As you can see, the p orbital of 2 boron atoms here will combine with s orbital of H atom. So that is how BHB bonding is formed. So the valence orbitals of each boron atom in diborane are sp3 hybridized. These are different types of bond that possibly exist in boranes. Firstly is 3 center 2 electron, where triply bridged boron-boron-boron bond is formed. But in this structure, only one bonding electron is originally belongs to boron atoms. The next one is boron-hydrogen-boron bridging bonding, also 3 center 2 electron types of bond, where both bonding electrons originally belong to B atom. This is the example that we have seen just now, where each boron atoms contributes to 1 valence electrons. Next is 2 center 2 electron, which is the normal boron-boron bond. One bonding electron is originally belongs to each boron atom, meaning that each boron atoms also contribute 1 valence electron. So total up there are 2 electrons. And lastly, 2 center 2 electrons for normal boron hydrogen bond. So the bonding electrons is originally belong to boron and also H atoms. Next, bonding in higher boranes. So this slide basically summarizes the calculation of framework electrons in higher boranes. Once we know the structure of higher boranes, we can determine the types of bonds that involve in the structure. So for example, we have seen diborane. There are 2 types of bonds, which is BHB bonds and also BH bonds. So in diborane just now, there are 2 BHB bonds that form bridge at the lower and upper part of the structure. So 2 times 2, that gives us 4 electrons, and also in diborane there are also 2 BH2 groups on the left side and on the right side. Each BH2 groups have 2 BH bonds. So in total there are 4 BH bonds in diborane. So 4 times 2 equals to 8. So we sum up total electrons and gives us 12 valence shell electrons in diborane. So the calculation is the same for other higher diboranes, where tetraborane gives us 22 valence shell electrons, pentaborane with B5H9 with 24 electrons, and lastly pentaborane B5H11 with 26 valence shell electrons. This is the calculation of the framework electrons. So yeah, when we know the structure first, we can determine the bonds, and when we know the bonds, we can calculate how many electrons that involved in the whole system. So I guess that is all for bonding in boranes. Thank you.
Okay, next, for the synthesis of boranes, Alfred Stock, who is the first person that synthesized the mixture of borane in low yield by treating magnesium boride Mg3b2 with hydrochloric acid HCl. So borane is also known as trihydridoboron with the chemical formula of BH3. So free pH3 is very unstable, but they can be isolated as stable adducts. Adducts is addition products with Lewis bases. For example, BH3 and NCH3. Today, synthesis of diborane, which diborane is the simplest boranes, can be prepared by compounds like lithium, aluminium hydride, or sodium borohydride, where we can react this sodium borohydride with BF3, we are going to get diborane here. We also can use reduction of boron trihalides with hydrogen, where we react the hydrogen with the boron trihalides, we also can get diborane. And the last one, hydride abstraction from BH4 negative species. This is the simplest method. When we react the BH4 negative with the boron trihalides here, X is halides, Cl, Br, it will also produce diboranes. Okay, hi, my name is Nidhi Mahazir. My metric number is 192597, and I will explain about the reactivity of borane. So borane is a diamagnetic and highly unstable compound because the boron in the borane has 6 valence electrons. Next, borane can spontaneously flammable in air. Next is the lowest borane, which is BH3. It's a very strong Lewis acid. And then other boranes are electrophilic, which they can accept electrons. Next is the higher boranes can be deprotonated when treated with a very strong base. For example, um, pentaborane 9 can react with sodium hydride, and the sodium hydride will deprotonate the proton in the borane. Next is borane also can act as weak acids, and then the reactivity of the borane decreases when the molecular weight increase, which is arachnoborane is the most reactive borane, and then followed by midoborane and prosoborane. So this is several type of reaction of boranes, which is electrophilic substitution, nucleophilic substitution by Lewis base, deprotonation by strong bases, then cluster building reaction with borohydrides, and reaction of nidoborane with an alkyne to give a carbonate cluster.